Hello class, today's lesson is over lessons 8 and 9, perimeter and the number line, ordering and comparing. Go ahead and pause the video if you need to copy down the title into your notes. Perimeter is the distance around a figure. So if you want to find the perimeter of a shape, add up the length of each of its sides. For example, if we have a trapezoid with sides 3 inches, 5 inches, 4 inches, and 7 inches, in order to find the perimeter, I'm going to add up those amounts. Five and 3 makes 8. 8 plus 4 makes 12. And then plus 7 makes 19. Inches plus inches plus inches plus inches gives me just plain old inches. On the homework, I'd like you to show that 19 inches is the perimeter by using a capital P and an equals in front of this. We use capital P to symbolize perimeter, and then circle your answer. Now we're going to talk about some special figures. First, let's talk about a rectangle. Remember, on a rectangle, that this side is the same length as this side, and this side is the same length as the one it's across from. So, the right side of the figure must be 5 centimeters, just like the left, and the bottom must be 8 centimeters, just like the top. So to find the perimeter, I need to make sure that I use all 4 of those. So 8 centimeters plus 8 centimeters plus 5 centimeters plus 5 centimeters. Remember, in addition, that the order doesn't matter so long as we do it all. So I would probably start with 5 plus 5 gives me 10. And then I would think 8 plus 8 is 16. And then 16 plus 10 gives me 26. Centimeters plus centimeters plus centimeters plus centimeters is centimeters. So the perimeter equals 26 centimeters. A square is a special kind of rectangle where all the sides are the same length. So if that bottom side is 6 feet, then the right is 6 feet, the top is 6 feet, and the left is 6 feet. So here we can do something a little bit different for perimeter. This time, since I'm adding 6 up repeatedly, I would actually just start with P equals, and then instead of adding 6 with itself 4 times, I'm just going to take the whole thing and multiply by 4. So the perimeter is 24 feet. A square can be called an equilateral quadrilateral, meaning that all the sides of the quadrilateral are the same length. While other figures can be equilateral as well. For example, here we see an equilateral triangle, or at least the best that I can do. So since this is equilateral, I know if the bottom is 2 yards, that the other 2 sides are 2 yards as well. So to find the perimeter, instead of adding that up 3 times, I'm just going to take it and multiply it by 3. So the perimeter here is 6 yards. Here we see what is supposed to be an equilateral hexagon. Use your imaginations a little bit. So if the bottom is 3 meters, then I know all the other sides are 3 meters as well. So therefore the perimeter is going to be 6 times the 3 meters. So the perimeter is 18 meters. Sometimes we'll be asked to work backwards. For example, in this problem we have a square and we're told that the perimeter is 36 inches. Well, squares are an equilateral polygon and therefore each side is the same length. But I don't know what that length is. I do know though that 4 times that length must be the perimeter, 36 inches. If I use the fact family method and think through this fact family, I know that s times 4 would equal 36. I know that 36 divided by s would equal 4, but most importantly, I know that 36 divided by 4 would equal s. If I do what this says, 36 divided by 4 gives me 9 inches. Each side must be 9 inches. A number line is a line that we typically use to represent the relationships between our numbers and the distances between them. On a typical number line, you'll find the counting numbers. Those are the numbers that we normally count with. So we usually use tick marks evenly spaced out, or at least as evenly as we can manage it. And the counting numbers include 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, on and on and on, as high as we can go. And actually the counting numbers go on forever because conceivably if we knew enough place values, we could write forever. The whole numbers are all the counting numbers and 0. So let's add 0 to our number line now. Negative numbers are all numbers less than 0. So typically on a number line, you'll find tick marks going left of 0, and they'll usually be labeled with negative counting numbers. So negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and so on. We can use a number line to help us compare numbers. We already know the further we go to the right, the bigger my number gets. And so as I move to the left, the smaller my number gets. So as we can see, all negative numbers will be smaller than all positive numbers. So if I take a look at the number line, I see negative 5 right here, but 2 is over here. Well, the number further on the right is going to be larger. So negative 5 is less than negative 2. So a less than sign is going to look like that. You can imagine a Pac-Man mouth eating the larger amount. You can imagine an alligator eating the larger amount. Whatever the case may be, I typically imagine an alligator eating that bigger amount. And that's how I've remembered it. But whatever helps you to remember it, go for it. So if we continue on to these others, notice that this next one is asking us to compare negative 1. Well, negative 1's there, and negative 1's there. It's the same amount. So when we compare numbers, they can also be equal. And then finally, if we compare negative 4 to negative 6, we can see that negative 4 is further to the right, so it must be bigger, which means my alligator or my Pac-Man is going to want to eat negative 4. And there we can see it now without my alligator in the way. When comparing numbers, it's important to write them in the same form. So notice here that I have two amounts written with dollar signs, but one with a cent sign. So my first step here is going to be to rewrite this so that they are all using dollar signs. Since we're dealing with money, it may also be helpful to put a decimal and 2 decimal places on each of these. Now, if I compare them, I can see that this is $2 with some change, this is only change, and this is $24 with no change. So if I wanted to put this in order from least to greatest, obviously I'm going to start with 24 cents. Next would come $2 and some change, and finally the largest, $24. On the homework, once you've rearranged this, I would like you to go back one last time and rewrite each amount back in its original form. And so that is my final answer. Sometimes you'll be asked to compare problems. For example, 36 divided by 12, then divided by 3, or 36 divided by 12 divided by 3 in parentheses. In a problem like this, I would like you to work out each problem individually. So if we start with the left, the first thing that I'm going to do here, following the order of operations, is work left to right. So I'm going to do 36 divided by 12 is 3. Bring down my divide by 3, and then obviously I only have one thing left to do, so I'm going to do it. 3 divided by 3 is 1. On the right, the first thing I'm going to do, following the order of operations, is parentheses. So my 36 divide comes down, and 12 divided by 3 is 4. And now only one thing to do, so do it. 36 divided by 4 is 9. So now, if I compare 1 to 9, obviously 9 is greater. So my alligator wants to eat the 9. Which means up here then, 3 divided by 3 must be less than 36 divided by 4. And then all the way up to the original problem, 36 divided by 12, then divided by 3, must be less than 36 divided by, in parentheses, 12 divided by 3.